We all know how endless our universe is, and that it is the main reason why the astronomers want to dive deeper and deeper into it in order to discover something new. Because one thing for sure is that the more you study the universe, the more you will find out about it. Although it is difficult to give an exact explanation what the universe is, we need to mention that we can detect the stars, the moon, the sun, the planets that give life to the universe, and make us always wanting to learn more and more. This couldn't happen without the help of astronomers who enjoy studying intergalactic events that give answers to many astronomical questions. In this video, scientists need to give answers to something that has been discovered and it is considered to be a mystery. Suddenly, a massive star disappeared. Let's start with our topic that has to do with a unique star. When we look up in the sky, we could see the sun, the moon, and the stars. And as we have mentioned before, the stars are astronomical objects consisting of a luminous spheroid of plasma held together by their own gravity. Consequently, the study of the birth, life, and death of stars is central to the field of astronomy. And what we know is that they are huge celestial bodies, made mostly of hydrogen and helium, that produce light and heat from the churning nuclear forges inside their cores. Stars are the most widely recognized astronomical objects and represent the most fundamental building blocks of galaxies. Imagine that our galaxy, the Milky Way, contains an estimated 300 billion stars, and we are able to perceive with the naked eye around 2,000 to 2,500 stars. It is worth mentioning that the stars have life cycles based on their initial mass. For instance, the larger a star, the shorter its life, although most massive stars live for billions of years. We do know that stars form in huge clouds of gas and dust. Gravity causes these clouds to contract, thus drawing the gas closer. As these materials accumulate in the center, density raises and pressure increases. This causes the matter to heat up and glow while the mass increases. Temperatures and pressure continually grow until hydrogen can be fused. The heat generated by this nuclear fusion causes the gas to expand, and when hydrostatic equilibrium is reached, the star is born, and we are able to observe and analyze them. One of these stars is known as Kinman Dwarf, or PHL 293b. The reason we are going to pay attention to this specific star is because something extraordinary happened, and our job here is to give further details, as what happened seemed to be difficult to comprehend. So let's take things from the beginning and let the journey begin. Before we continue with our exploration to PHL 293b star, be sure to like or dislike the video so that we can continue to improve and make these videos better for you, the viewer. Plus, be sure to subscribe to the channel so that you don't miss any of our weekly videos. The PHL 293b star belongs to the dwarf galaxy in the constellation of Aquarius, and it lies approximately 75 million light-years away. Let's take a closer look at this galaxy. A dwarf galaxy is a small galaxy composed of about 100 million up to several billion stars. Dwarf galaxies' formation and activity are thought to be heavily influenced by interaction with larger galaxies. Astronomers identify numerous types of dwarf galaxies based on their shape and composition. A good example of a dwarf galaxy is the Large Magellanic Cloud, located about 160,000 light-years from Earth. It contains about 1/10 the mass of the Milky Way and has about 10% of its stars. Two other dwarf galaxies are even closer to the Milky Way and have been captured by our galaxy's gravity. Other dwarf galaxies are just remnants that have been torn apart by the Milky Way's gravity and are currently being incorporated into the structure of our galaxy. The massive star PHL 293b is one of the brightest and largest stars known to date, and many astrophysicists claim that we may have detected one of the most massive stars of the local universe going gently into the night. At this point, we need to mention that massive stars are among the most important sources of ionizing photons and chemical elements, producing a significant proportion of the elements currently present in the universe. They are instrumental to the understanding of a variety of astrophysical topics, including the link between supernova and gamma-ray bursts to the nature of their respective progenitors, as well as the early evolution of the universe. Let's go back to PHL 293b now. The star is considered to be 2.5 million times brighter than our Sun, and scientists have been studying PHL 293b for a long period of time. To be more specific, in the 2000s to 2010s, astronomers started observing the giant star, and for these 10 years they have been studying this mysterious star in this galaxy, and their observations indicated that the star was shining brightly, especially between 2001 and 2011. Different teams of astronomers were regularly observing the star to obtain more information, and they discovered that this star is in a late stage of its evolution. So you can understand that there was curiosity for this star for some reason, and astronomers' curiosity led to a discovery that would become the beginning of another scientific exploration. What I'm saying is that in 2019, ESO's Very Large Telescope couldn't find the star. When they tried to study it once again, PHL 293b was no longer at its place, and there was no trace. For some reason, it suddenly disappeared, and they could no longer find signatures of the star. It came as a surprise the fact that the star had disappeared, and something really interesting is that there were no signs of a star explosion. The star was located 70 million light-years away from our planet, but still we were able to detect it, and astronomers aren't sure why the star is invisible. It's a little hard to figure out exactly what happened, and it is even harder for astronomers to understand why this star vanished. And the reason why it is difficult for them to understand how it disappeared is because stars cannot disappear like this in an instant moment, especially this star that was observed by astronomers for over a decade. It would be highly unusual for such a massive star to disappear without producing a bright supernova explosion. Typically, at the end of a star's life, it will go supernova before turning into either a black hole or a neutron star. This violent stage is hard to miss and can last for years. Astronomers likely would have caught sight of the explosion. A question that needs to be answered is, how were we not able to detect the vanishing of the star? Being located 75 million light-years from Earth means that astronomers are unable to distinguish individual stars within the Kinman Dwarf Galaxy, but they are able to determine signatures from those stars, and crucially in this case, can tell one of those signatures is missing. During the observations made between 2001 and 2011, the signature of a luminous blue variable star was distinguishable in the galaxy's light output. Astronomers were also able to determine that the blue variable star in question was around 2.5 times brighter than our own star. Even though blue variable stars such as this one are unstable and show sometimes dramatic shifts in their spectra and brightness, even with these changes accounted for, researchers can spot the traces of such an object. The team used the Echelle spectrograph for rocky exoplanet and stable spectroscopic observations, ESPRESSO, instrument attached to the VLT to make their initial observations in August of 2019. Failing to find the star's signal with ESPRESSO, one of the most powerful and precise planet-hunting devices on Earth, the team followed up this initial investigation with VLT's X-Shooter instrument. This follow-up search confirmed their findings. Using the European Southern Observatory's Very Large Telescope, VLT, astronomers have discovered the absence of an unstable massive star in a dwarf galaxy. This discovery wouldn't have been made without using the powerful ESO 8-meter telescope, their unique instrumentation, and the prompt access to those capabilities following the recent agreement of Ireland to join ESO. It is worth mentioning that Ireland became an ESO member state in September of 2018. Based on their observations and models, the astronomers have suggested two explanations that could be distinct possibilities for the star's disappearance and lack of supernova related to this possible outburst. The outburst may have resulted in the luminous blue variable being transformed into a less luminous star, which can also be partially hidden by dust. So it has been suggested the star may have been shrouded in a thick fog of gas and dust, obscuring it from view. Near-infrared observations taken in 2009 suggest this cloud of gas and dust would need to be extremely cold in order to shade the star undetected. Alternatively, the team says the star may have collapsed into a black hole without producing a supernova explosion. However, evidence has started to emerge that stars can indeed collapse directly into black holes without undergoing a supernova explosion. It's not impossible that the star underwent an undetected supernova, but such a massive star as a luminous blue variable would be expected to produce a supernova afterglow that shines in the sky for at least 5 years following. This would be a rare event. Our current understanding of how massive stars die points to most of them ending their lives in a supernova. So there's a really exciting possibility that the star collapsed down into a black hole without the supernova that has previously been thought a necessary component of such events. The old data indicated that the star in the Kinman dwarf could have been undergoing a strong outburst period that likely ended sometime after 2011. Luminous blue variable stars such as this one are prone to experiencing giant outbursts over the course of their life, causing the star's rate of mass loss to spike and their luminosity to increase dramatically. If something like this is true, that means that this would be the first direct detection of such a monster star ending its life in this manner. It would be part of astronomical history. If this is the case, then not only must these events be extremely rare, it could challenge what we know about the death of stars, something new to be added to the discoveries of astronomy. I think it is very fascinating. It's impossible to know for certain with the current data. Only future observations across a range of wavelengths can shed light on the mystery of the missing star. Future studies are needed to confirm what fate befell this star. Planned to begin operations in 2025, ESO's Extremely Large Telescope, ELT, will be capable of resolving stars in distant galaxies such as the Kinman dwarf, helping to solve cosmic mysteries such as this one. Fortunately, investigations into this stellar disappearance are set to continue. The ESO's Extremely Large Telescope, ELT, is due to begin operations in 2025, and it should be powerful enough to resolve individual stars. Based on these findings, the ELT will undoubtedly be turned towards the Kinman dwarf galaxy in search of this missing star to determine its final fate. As we come to an end, we need to say that this isn't the first time a star has completely vanished without a trace. In 2017, astronomers were stunned when a red giant star 22 million light-years away in the Fireworks Galaxy suddenly disappeared. Thanks for watching.